title. It might be kind of an unexpected surprise. So I think that's reasonable too. In short, there is no right answer here. And in fact, part of the process of getting better at programming is getting your own sense of style, or working for a company where they might prescribe which way is better than the other because they just want everyone doing the same thing, even though reasonable people might disagree. Ultimately, though, so long as you have what's a pretty good argument in favor of one way or the other, like ultimately that's what's important. If you're just doing things because you don't really know which one's better, that's not great. But if and when you start to acquire opinions, and if your boss, if your teacher, if your colleague, your friend can challenge you and say, wait, why did you do it like this? They might not agree with you, but at least have an answer, and that should be sufficiently persuasive in general. Now, strings come with a whole bunch of other methods as well, among which is one called split, which can, as the name suggests, split a string into multiple smaller substrings, so to speak. For instance, if the human here is in the habit of typing in their first name, then a space, and then their last name, and you want to go ahead and greet them only by first name, well, we could actually leverage that single space between the first name and last name and split that string into two smaller substrings. How can we do this? Well, let me go ahead and in between these lines proactively comment that we're about to split user's name into first name and last name. And then let's go ahead and take that name variable, which currently contains something like, presumably, David space Mahlon. And let me go ahead and call split and pass in as the argument to split a single white space, thereby indicating that I indeed want to split on that character. Now, it turns out split's going to return a sequence of values, ideally a first name and then a last name. And we can actually, in Python, assign both of those values from that sequence at once to some variables. For instance, first, comma, last equals, and that's going to have the effect from right to left of putting the first such value in the first variable, the second such value in the second variable. So now, on my last line of code, I can go in and say hello, not to the full name, something like David Mahlon. I can just say hello, comma, first. All right, let's go ahead and clear my terminal window, run Python of hello.py, and hit enter. I won't bother with any leading white space this time, but let me go ahead and type in David space Mahlon, and crossing my fingers as usual, hello, David, is what we now see. All right, so we've seen so many examples thus far involving strings, but certainly programs and programming languages can manipulate other types of data as well. Let's go ahead and transition then to another very common type of data in Python, in programming more generally, namely integers, otherwise known in Python as int, int. So just as str, str, is short for string, so is int in Python short for integer. Well, what's an integer? Well, just like in math, it's a number like -2, -1, 0, 1, 2, and all the way toward negative infinity, all the way toward positive infinity. But there's no decimal point in an integer. It's just a number like -2, -1, 0, 1, and 2 onward. That's an int. Of course, in the world of mathematics, there's lots of symbols that we use, and we've seen it. Of course, in the world of mathematics, there's lots of symbols that we use, and we've seen plus before, although we used it for a different purpose. But Python supports these symbols and more. And Python allows you to add numbers together, plus, subtract numbers, multiply numbers, divide numbers. And the only one here that might look a little strange to people or unfamiliar is this percent sign, but it doesn't mean percent in this context. If you use a single percent sign in a Python program, that's actually the so-called modulo operator, the operator that allows you to take the remainder after dividing one number by another. So we'll see examples of that before long, but the first four of these are perhaps quite familiar. Well, it turns out that in Python, you don't necessarily have to keep writing code in a file like hello.py and then running it in a terminal window. One of the features that many people like about Python is that it supports this, a so-called interactive mode. Like you can start writing Python code and immediately execute each of those lines interactively, especially if you don't care about saving all of your lines of code. You just want to execute code and get back some answers. So for instance, let me go back to VS Code here, and let me close hello.py, and let me click on the little triangle over here in my terminal window just to make it much bigger, just temporarily for a moment. So I'm not creating any .py file now. I'm just going to run Python by itself at my prompt. And you'll see when I do this, I get some cryptic looking output and the date and time at which the program was last updated and so forth. But I ultimately get output. So I'm going to go over back to the lines of you interact with Python. You don't necessarily have to keep writing code in a file like hello.py and then running it in a terminal window, one of the features that many people like about Python is that it supports this, a so-called interactive mode. Like you can start writing Python code and immediately execute each of those lines interactively, especially if you don't care about saving all of your lines of code. You just want to execute code and get back some answers. So for instance, let me go back to VS Code here, and let me close hello.py, and let me click on the little triangle over here in my terminal window just to make it much bigger, just temporarily for a moment. So I'm not creating any .py file now. I'm just going to run Python by itself at my prompt. And you'll see when I do this, I get some cryptic looking output and the date and time at which the program was last updated and so forth. But I ultimately get 3 triple brackets like this. This is the interactive thread itself at my prompt. And you'll see just to make it hello to code and get back some answers. So for instance, let me go back to VS Code here, and let me close hello.py, and let me click on the little triangle over here in my terminal window just to make it much bigger, just temporarily for a moment. So I'm not creating any .py file now. I'm just going to run Python by itself at my prompt. And you'll see when I do this, I get some cryptic looking output and the date and time at which the program was last updated and so forth. But I ultimately get 3 triple brackets like this. This is the interactive mode for Python. So I'm running the Python interpreter, and anytime I type a line of code in the interpreter, it's going to execute it immediately. I don't have to keep running Python again and again. It's as though in the human world, if you were standing next to a human who speaks some other language and you're just having a conversation with them back and forth, it's all happening, the translation immediately. So what might I do in interactive mode? Well, I could do something like 1 + 1, enter. That's actually code. All right, you might not think of it as code, but if you know a bit of arithmetic and you know numbers and you know plus, that's valid Python code. And you can use Python really as a fancy calculator. But I could do other things too. If I want to print to myself hello, comma, world, I can also print out that line of code there too, hello, world. So it's interactive in the sense that the moment you execute a line of code, boom, you see the result. We're generally not going to do that because at least when teaching the language, we tend to want to do things incrementally. And we want you to be able to see where it is we came from. And we want to be able to try things again and again, especially if we make mistakes. But know that this is indeed a feature of Python, this so-called interactive mode. But let's focus for a moment now, not just on that interactivity, but really on the fact that Python apparently supports integers and mathematics and some of those basic operations. And let's see if we can't make maybe our own little calculator. So let me go ahead and open up VS Code again. And I'm going to shrink down my terminal window. And I'm going to create a new file called calculator.py. So to do that, recall, I can type code down here. And the name of the file I want to create, .py. Enter. That gives me a new tab up top. So I have already closed hello.py. I'm now in calculator.py. And let's just make a simple calculator that does some addition for me. But I'm going to do it in a file so that we can iterate on this and make changes for better or for worse over time. Let me go ahead and first declare a couple of variables. I'm going to do the mathematical thing of calling my first variable x, my second variable y, and then I'm going to give myself a third variable, z equals x plus y, and then I'm going to go ahead and print out z. Now, this program, admittedly, not very exciting or interesting. In fact, it's a little less interesting than printing stuff on the screen like before with strings. But we'll build on this and see what other features exist in Python that we can leverage. So hopefully, if Python knows its math as well as I do, when I run Python of calculator.py, I should see, hopefully, that 1 + 2 equals indeed 3. All right, so not that surprising and not that interesting. And honestly, this isn't the most useful program because it's always going to calculate 1 + 2 equals 3. Let's at least make this program, say, a little more interactive, right? We already know from previous examples how we can get input from the user. Let's bring back that input function. And let's do this. Let me go ahead now, and at the top of my code, let's change x to not be the number 1 always. Let's change it to be whatever the return value is of asking the user for x. And I can use any English or human language I want here. I'm going to say, what's x? Just like I asked before, what's your name? And I'm going to do the same thing for y. I'm going to use input again, but this time change the question to be, what's y? All right, at this point, I think I'm going to leave the rest of the code the same, z equals x plus y, and then print z. But what's nice now is that I think I have a nice interactive calculator. Right now, it's not going to do 1 + 2 all the time. It's going to do whatever the user types plus whatever the user types. So let's try this. Let me go ahead and run the program. All right, let's do it. 1 is going to be x. 2 is going to be y. And of course, everyone in agreement, 1 plus 2 equals 3. Huh. What's going on there? Either your math class misled you or I have misled you. Why don't we call on someone here to see if you can help us reason through what the bug is. What's the mistake? Anjali, I'm saying it right?
I think the issue is that it's concatenating strings because you use the plus operator instead of adding.
Perfect. So perfect intuition. We've seen that plus is used a little differently in the context of strings because it concatenates. That is, it joins the two strings. And that seems to indeed be what's happening here, even though the user typed a number. But the interesting thing here is that when you get user input, because they're using a keyboard on their Mac or PC or their phone, it is always going to be text. It might look like a number, but by default, it's coming from the keyboard as a string. That is as text. And so how do we go about resolving this if ultimately we don't want to treat those inputs as strings, we want to treat them as actual numbers? Well, we need another function. And it turns out in Python that you can convert sometimes from one type of data to another type of data, for instance, from string to int, by doing something like this. Let me go back into my code and let me change x before adding it to y to be whatever the integer version of x is, plus whatever the integer version of y is. So it turns out that int is not only a type of data in Python, it's also a function. And it's a function that if you pass in an input, like a string, so long as that string looks like a number, like 1 or like 2, it will convert it to an actual number that you can perform mathematics on instead. So if I now go back to my terminal window and run Python, and let me show you another trick. Calculator is kind of a long word. It's a little tedious to type. Notice what I can do in my terminal window in a command line interface in general. If I start typing CAL for calculator, I can actually hit tab to finish my thought. So autocomplete is possible in a terminal window like this. Type the first letter or few letters, and then boom, with tab, it'll finish your thought for you. Or you can go back in your history like I did with the up and down arrows. Let me go ahead and execute this. What's x? 1. What's x? 2? And there we go. Now we have a general purpose calculator that's going to support not just addition of 1 and 2, but now any two integers that the user types. And let me now improve this, right? We've seen how we can make improvements to code. And I don't know if it's going to necessarily be better, but let's try this. Do I really need the z variable? It's worth noting that I'm creating a variable called z, and then I'm immediately using it on the next line of code. Now, that's not that compelling because if you're creating a variable and then immediately using it but never again using it, did you really need to take the time to introduce another symbol and another variable just to use it once and only once? Well, maybe not. Maybe we don't really need z in this way. Maybe I should go and do something like this. Maybe I should get rid of z here. Maybe I should change this to be int up here, change this to be int up here, doing something that's pretty interesting now. Even though it's a bit of new syntax, notice that you can nest functions, so to speak. You can put one function call, that is the use of a function, inside of the use of another function so that the return value of the inner function becomes the argument to, or the input to, the outer function. So just like in math, if you have parentheses, 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 your teacher probably taught you to focus on what's inside the innermost parentheses first and then work your way out. Same thing with programming. That's what Python's going to do. It's going to look at what's inside of the parentheses first. It's going to get the answer, and then it's going to pass the return value to the outermost function. So what happens on line 1 now is that the input function gets called first. Then the result of that, quote unquote 1, becomes the input to the int function. And same on line 2. The output of what's y becomes the input to this int function. And now there is no z. I could just do print x plus y. And because I've taken the time to convert each of those strings to an integer, I think we're OK. So let me try this. Python of calculator.py, enter 1 and 2. And we're still getting 3. Not 12, or not 12, 1, 2. We're indeed getting 3. And we've additionally gotten rid of the variable because we didn't necessarily need it, it seems, especially if only using it once. Well, here too, let me put everyone's hands down for just a moment and let me ask, as before, this version now, which uses int around the invocations of input and does not use z, is this better than the previous version? If you want to vote yes, go ahead. Or if you prefer the old way, vote no. The old way, I'll undo all of this as we vote, instead looked like this. All right, and let me go back to now the newest version. Let's take a hand of the yeses. Someone who thinks this latest version is better.
I think this way is better because it allows us to immediately see what the x and y variables are with integers, and so we know what to expect from them. And also the print argument is more intuitive. We avoid too much clutter in the code.
I think those are all good reasons. It's nice and succinct. The lines of code are not very long. I don't need to know what z is because it doesn't exist. It just see print x plus y. I like that. But someone who prefers the older way, where we did have z and we more explicitly passed individual variables to the int function.
Yeah, hi. I think the earlier version is better because when, if user input something else other than int, let's say they type 1 and 2, so it will be easier to debug.
This version or this version here or the old version?
The old version.
OK, that's fair. And in fact, I'm being very careful today as best I can not to mess up. I have thus far only inputted integers when I'm expecting integers. And Raul's actually pointing to something we'll come back to in the coming weeks. How do we actually handle errors? What if the user doesn't type in the number 1 or the number 2 or a number at all? What if they type in a word like cat, C-A-T? That's not a number, and I bet I can't convert it to an integer. But for today, I'm not going to focus on that. I'm just going to hope that the user cooperates, but that's not going to be the case. And so perhaps one way would set us up for more success when it comes to handling those errors. Now, for today's purposes, which is better? I like both. And I think both of you made very valid arguments in there too. So long as you have a justification that feels pretty reasonable, that's what ultimately matters. But acquiring, again, a sense of the trade-offs here. Well, is this way better? If so, why or why not? Just understanding what those trade-offs are. But generally speaking, prioritizing readability is a very good thing. Making your code readable for someone else is a very good thing and very good for you too, so that when you wake up the next morning or you come back the next week or the next year, you too can read your own code without having to waste time trying to remember what you did. And simplicity tends to be a good thing too, keeping your code simple. So as you get more comfortable with programming, you might be tempted to try to combine an entire program into one long line. For instance, let me do just that. Technically speaking, we don't really need x in a variable. We don't really need y in a variable. We could also do this. I could just get rid of x and y altogether. I could then now eliminate that and make it just one line of code. OK, so in some sense, you might be inclined to think, wow, that's really nice. You made it one simple line of code. I would argue this actually isn't that simple. Now I think I'm starting to nest too many things. I have to think about print and int and input. I then have to notice that, OK, I've opened 2 parentheses. I've closed 2 of them. There's a plus. You're making me think too much. And anytime you make me think, you're wasting time. And anytime you complicate the look of the code like this, you're just going to increase the probability of mistakes, syntactical mistakes or logical errors in your code. So of all the things we've done, this is the only one that I would argue, yes, it's one line and it's nice and compact. It's just not readable enough. I would shy away from doing this, especially since 2 of those function calls are getting input from the user. But there too, reasonable people might disagree. But that's the kind of visceral reaction you should have sometimes when code starts getting a little too complicated, a little too clever, perhaps for its own good. All right, well, it's not just integers we have access to. Let me propose that we transition from integers to one more data type here, namely a float. So again, a string is a sequence of text. An int is an integer, like -1, 0, and 1. A float is a number with a decimal point. properly called a floating point value, and you can think of the floating point as being the decimal that might be over here or over here with some number of digits to the left or the right. Mathematically, it's a real number, a number that has a decimal point in it. So that's a third type of data that Python supports. Right now, our calculator is somewhat naively assuming that the user is only going to type in integers. But if I want to support floating point values too, I think I can just make a couple of tweaks. So I'm going to go back to VS Code here, and instead of just converting the user's input, x and y, to integers on line 1 and 2, let's just make a simple change. Let's actually convert it to a float on the first line and a float on the second line here. Now I think if I go down to my terminal window and run Python of calculator.py, let's type in a number like 1.2 with a decimal point, enter. So that wouldn't have worked before floating point. But suppose that I don't do like 4.6. I float the nearest possible in some functionality built in. And in fact, if we return to this URL from earlier, wherein all of the Python built-in functions are listed, there's one called round, which does exactly as we would expect. It takes as input a number and then rounds it for us, for instance, to the nearest digit, to the nearest integer. But if we look a little closer at that documentation, as we can here, I'll provide an excerpt. This is what the function looks like in the documentation. And recall that earlier we looked at the documentation for print, and this is similar in spirit, that this shows us not just the name of the function, but its available parameters. That is, inputs that we can provide when using this function. But this is a little cryptic too, just like print was, and it adds some syntax. So let's see. The name of this function here is, of course, round, and its first argument is a number. Notice this time there's no star. There's no star objects like there was for print. The round function takes just one number as its first argument, period. That's its positional parameter. But notice this syntax, and this is a convention in programming or technology more generally. Generally speaking, when you see square brackets in documentation like this means that you're about to see something optional. And so what this means is that if you want to specify more precisely the number of digits that you want the round function to round to, you can specify it here by adding a comma and then that number. So if we read the documentation, if you don't specify a number of digits, you just specify the number to round, it rounds to the nearest integer. But suppose you want to round to the 10th place or the 100th place, that is 1 or 2 digits after the decimal point, you could additionally pass in comma 1 or comma 2 to be more precise. So that's what the documentation there is saying. Let's see if we can't then translate this to some actual code for us. So if I go back now to VS Code and I consider that I want to go ahead and round x and y, I can do this in a couple of ways. I could do round x plus y, but I'd actually kind of prefer to break this now out into 2 lines. I don't have to, and reasonable people here might disagree, but I'd like to revert to a scenario where I'm printing z so that I can just a little more clearly to myself, to others, say z equals the rounded result of x plus y. It's not necessarily the better way to do it, but I'm a little more comfortable with breaking out my thoughts one at a time, especially if I want to start commenting each of these chunks of code. All right, let me go down to my terminal window now and run Python of calculator.py. What's x? Let's do 1.2 again. Then let's do 3.4. And now it was previously 4.6, but now it's been rounded up to the nearest integer, which of course is going to be 5. All right, what if I wanted to change this a little further? What if I wanted to support maybe really big numbers, irrespective of rounding? Let's just do something like this. Let me go ahead and run Python of calculator.py again. And let me just add 999 plus 1. And notice I don't have to type decimal points. Even though I'm converting to float, my program will just allow me to type decimal points, but I don't need to oblige. The answer, of course, here should be, and is in fact 1,000, whether or not we round. So that's just arithmetic with integers here. But in the US, we tend to format long numbers by putting commas after or before every triple of digits. Other countries flip it and they use periods and commas instead. That's a system setting. You can change that on your own Mac or PC or device for Python or any language. But for me, I'm using the US approach here, which is periods for decimal points and commas for separators. What if I wanted this to be outputted as 1, 0, 0, 0? just to make it a little more clear that it's 1,000 and not something like 100. That's even more useful when it's like 1,000,000, 1, comma, 000, comma, 000. Wouldn't it be nice if we could automatically output those numbers as well? Well, it turns out that we can. There is a way using Python to actually specify that we want to include commas like this. And here we have an opportunity to bring back our old friend, the f string. First, let me do something that's not that productive. First, let me do this. Let me print out the value of z, but wait a minute. I can't just say quote unquote z, because that's literally going to print z on the screen. So let me wrap it with those curly braces like I did before, but that too was not enough. I literally needed to add an f at the beginning of my string to tell Python that this is an f string, a format string. That now is going to print out, not very interestingly, just the value of z itself. So that I'm going to great lengths just to print z, when really I could have just passed z as the sole argument. But just to ensure that I haven't broken it, let's do this again. 999 plus 1, enter. OK, it's still 1,000. So I didn't make anything worse. But notice, and this syntax is unfortunately a bit cryptic, notice that I can actually do this. I can put a colon after the z, and I can put a comma thereafter. This looks very cryptic, admittedly. And even I have to constantly look things like this up in the documentation to remember the syntax. But here, let me run it again. Python of calculator.py, 999, 1, and now notice that the number has been automatically formatted for me. If I were in a different country or locale, I could absolutely override this to use periods instead of commas or vice versa. But in this case here, it's just happening for me automatically. So there, too, we see a hint of what it means to really format a string. There's even more power, more powerful capabilities built into that. All right, let me pause here to see if there's any questions now on floats.
Yes, you can.
Floats cannot represent numbers infinitely precisely in a nutshell because computers only have so much memory. They only have a finite amount of memory. You and I only have a finite amount of hardware inside of the computer. So at some point, they're going to have to round. Right now, I'm rounding automatically. Effectively, computers will eventually have to do that for us. But we'll see that as a fundamental problem before long. Allow me to turn back just for a few final examples on float before we introduce a few final examples that allow us not just to use functions, but to make our own. Let me propose that we also try our hand at a bit of division here. Let me propose that we modify this calculator now to still take a couple of floats, but let's now just do something a little simpler than, a little different from this, just doing x divided by y. And let me go ahead and get rid of my format string and just keep it simple for now, printing out z instead. And what are we going to see here? Well, just some simple division. So Python of calculator.py, let's do something like 2 divided by 3. And of course, I get 0.66666. And to Ethan's question a moment ago, it does seem to be finite. It's not rounding in a weird way here, but I only seem to see so many digits. That's an inevitability of using a float in this way. By contrast, just so you know, integers nowadays in Python can be as big as you want them to be. Unlike other languages, there is no upper bound on how big an int can be now in Python, but there is a bound on just how precise a floating point value can be. All right, now that I've got some simple division working here, let's go ahead and round this. It would be nice to round this really long number, 0.6666666, and so forth, to maybe just 2 decimal places. We've seen how to do this with round, though, at least in its documentation. Let's just round this, not to the nearest int, by passing in just x divided by y, which is one argument. Once the math is done inside of the parentheses, I don't want to pass in just one argument. I want to pass in 2 so that I can specify n digits, number of digits, which recall was the second parameter for round. Let me go ahead and run Python of calculator.py. I'll do the same thing, 2 and then 3. 0.67. So here, too, we see a way of rounding now, not just to a nearest integer, but to a nearest number of digits. But there's another way to do this here. And in fact, this evokes our f string example again. You didn't want to beginning and exited after, like before, is very cryptic thing, especially weird. We get the very string approach to that very same problem. All right, which one is better? It depends. In this case, they're pretty equivalent. You could imagine, though, it being useful to use a function sometimes so that you can pass in an argument like n digits as that second argument.
I think it's crazy that an hour into this, we just cover the basics. Maybe some like ints, parameters, just like basic prints and all that shit. And then now,
or you can imagine just deciding in advance that you want 0.2 and then
6 hours,
writing it like
7
this.
hours of going right at it.
Let's transition now
But the only reason I'm even doing this one is one, because it's a Harvard class, but then two on top of it. They have a whole bunch of projects to do, so I can actually go through and enter these up. The issue I was running into with Bro Code was I was just kind of just doing tutorials, and I don't know. I just want a little bit more detail. This one goes over documentation. There's extra notes and etc. So I'll probably end up doing both, but I just wanted to slow down a little bit and relax and kind of get a grip on the fundamentals.
From focusing on strings and on integers and on floats to focusing now on functions themselves. We began today by focusing on how you can use functions that come with Python. But wouldn't it be nice if you could invent your own functions, especially if, to our point earlier, you find yourself solving the same kind of problem again and again? It's nice that Python comes with the print function, because it's really useful to be able to print things on the screen. But wouldn't it be nice if you could print specific things on the screen by just calling your own function? Well, let me propose that we do this. Let me go back to VS Code here, and let me propose that we go back to hello.py. I'm going to reopen hello.py where we left it before, and I'm going to go ahead now and propose that we consider how we can start improving this further by making our own function. I have written so many programs today that just say hello. And each time I'm using print, but wouldn't it have been nice if from the beginning of today we could just call a function called hello that just says hello for us? Now, the authors of Python years ago didn't think that we need a special function just to say hello, but I would like that to exist. I'm saying hello so many times, I just want to be able to call a function hello. So I'm going to start from scratch here. I'm going to delete all of my code from earlier, and I'm going to pretend for the moment that a function called hello exists. And I'm going to do just as I did before. I'm going to get the user's name with the input function, asking what's your name, question mark. And now I'm going to call a function hello, and then I'm going to print out the user's name. Now, I will admit hello doesn't exist, so bad things are about to happen, but let's see what. Let me go down to my terminal window. Let me run Python of hello.py. I think the first line is going to be OK, because that worked before. And indeed, it's prompting me for my name. So let me type in David. The second line of code is apparently calling a function that looks like it's called hello, because why is it a function? It has a parenthesis and a closed parenthesis immediately after it. And that's what every function we've used has looked like. But Python's not going to recognize this one. When I hit enter now, I get a name error. Name hello is not defined. Did you mean help? I didn't, although it's opportune. That's what I need at this point, is some help. But I am encountering this error because why? The function just doesn't exist. So how do I make this function exist? Well, I need to create it myself using this keyword, def. Def for define. So here too, just as str is short for string and int is short for integer, def is short for define. If and when you want to define, create, invent your own functions, you can do so using now this keyword in Python. So let me go back to my code here, and let me propose that we define this perhaps in this way. At the very top of my file, I'm going to first take a moment to define a function called hello using def hello, open parenthesis, close parenthesis, colon. What this means now is that Python is going to treat every line of code that I indent underneath this one as the meaning of this new function hello. So def is important, as is the space. I get to choose the name of the function, and I'm choosing to call it hello. The parentheses with nothing inside means that this function at the moment is not going to take any inputs, no arguments there too. The colon means stay tuned for some indentation. Everything that's indented beneath this line of code is going to be part of this function. It's going to be a super short function, one line of code. It's just going to print out, quote unquote, hello. But now, on lines 1 and 2, I have invented my own function, hello. Notice these dots that have now magically appeared here. This is just a setting of my text editor, VS Code in this case, that's just making super explicit to me that I've hit the spacebar 4 times, or equivalently the tab key once, which is converted automatically to 4 spaces. Generally speaking, I'm going to need to make sure that all of my indented code lines up now so that Python knows that it's all part of the same thing. But it's easy in this case because it's just a single line. But now, thanks to lines 1 and 2, the function hello will absolutely exist when I'm ready to use it on line 6. So let me go down to my terminal window and run Python of hello.py, enter. Here comes my name again. And now, when I hit enter, I now see hello, David. All right, we've kind of regressed though, right? This is not nearly as pretty as it once was. I think we can probably do better than this by improving things further, why don't we consider, though, how we might, say, parameterize this same function? That is to say, can we customize hello to maybe take the user's name as input so that we can say not only hello, but the person's name all on one line, all in one breath? Well, I think we can do this. Let me propose that we do this as follows. Let me go ahead and up in my code, let me, inside of these parentheses, let me come up with my own parameter name. I have complete choice here, and I'm going to say that the name of my parameter will be the word to. Why? Because I want my function to sound like the verb it represents, hello. But who do you want to say hello to? Well, I'm going to call my parameter for this function to, just because in English it kind of sounds nice to me. Hello to. Who do you want to say hello to? That's why I'm calling this parameter to instead of something simpler like x or y or z. All right, well, what do I want to do with the word to? Well, I can do a couple of different things. We've seen like so many different ways to implement hello. Let me just add a comma there for grammar's sake. And then let me put the word to after that as the second argument to the function hello. There's other ways we can do this, and we've seen so many, but this one looks a little clear to me, I'll say. What's going to happen next? Well, I don't think I need this extra print line here. I think what I'm going to do is this. I'm going to go ahead here and print out not the person's name manually. I'm going to instead say hello parentheses name. So what am I now doing? On lines 1 and 2, I'm defining my very own function called hello. But this time, that function has been designed to take a parameter, a single parameter, as input. And I'm using the value of that parameter, which I called to plug into print so that I see not only hello, but also that person's name. What am I doing on line 5? Same as always. I'm just getting the user's name. Line 6, I'm not only calling hello, I'm passing as input the name variable as an argument so that that's what gets passed into hello. And what's happening here is essentially this. Even though the variable is called name here, when the function itself is called, the computer assumes that that same value is now called to. So name is essentially copied to another variable called to, so that in the context of hello, I can say hello to that variable instead. And we'll see in a moment what happens if we don't keep those straight. Let me go ahead and run Python of hello.py, enter. What's your name? And now I'm crossing my fingers, enter. There we go. We're back in business. But now I have my own custom function called hello that's allowing me to say hello to a specific person. And here's where now things can get really fancy. What if you wanted your hello function to say hello to someone specific, but you know what? If you don't know who you want to say hello to, you want to say hello to the whole world, you can give parameters default values. We've seen that. Recall that with print, there was a default value for sep, for the separator. There was a default value for end, the line ending. We can do that too. And here's the syntax. If you want the value of this parameter by default, if not provided by the programmer, to be equal to quote unquote world, you literally do that in the same line you're defining the function. And I'll admit it's starting to look more cryptic, but I'm still just defining a function called hello. It takes a parameter called to, but I'm assigning it with the equal sign a default value of quote unquote world just in case the programmer doesn't call hello with an argument. And we can see this here. Let me change my code to use hello in two ways. On line 5, I'm going to very simply call hello, no arguments. Then on line 6, I'm going to get the name. Line 7, I'm going to call hello with an argument. So you'll see hello now being used in two ways. Let me go ahead and run Python of hello.py. I'll type in my name. Oh, interesting. Notice I already see hello world, but that's expected because line 5 happens before line 6. But once I type my name, now the program's going to be a little more polite and say hello to me personally. So there too, we see with relatively simple but new syntax how you can implement functionality very similar in spirit to what the print function gave us automatically. Now you have control over doing that yourself. But let me now make this point too. One of the whole points of defining your own functions is, one, just to avoid having to repeat yourself again and again. You don't have to actually keep reinventing the wheel and keep using the print function again and again and again if you just want to say hello. Wouldn't it be nice now if I could kind of move this code that I wrote for defining the hello function, and just to be dramatic, I'm going to hit enter a whole lot of times, 50 lines down, and put my definition of hello way further down in this file. Why? Well, just in the spirit of out of sight, out of mind. Because if I now rewind to the start of my program, now you can sort of take for granted that, oh, hello is a function. Why? Because it's there on line 1 and it has an open parenthesis and a closed parenthesis, which up until now has meant call this function. And then on line 2, we're getting a variable from the user by typing in their name, and then we're calling hello, passing in that value. Well, at this point, I can just take for granted that hello exists, even if it's way down further in the file, or as we'll see in future weeks, even if it's in a different file altogether. But there's a problem here. And let me go ahead and run this version of hello.py. Notice that as soon as I run the interpreter, Python of hello.py, I see a name error. Name hello is not defined. Again, did you mean help? Well, again, fitting. I do need some help here, but I didn't mean to call the function help. The problem here, though, is that Python is just taking me literally. I have defined my function hello all the way down here, but I'm trying to use it way up here, and that's not allowed. Python's interpreter is going to take you literally, and if you use a function, it must already exist by the time you are calling it. So how do I fix this? Well, apparently I can't do that. I have to define any functions I want at the very top of my file. But that too could get me into a bit of trouble eventually, because if I constantly have to define a function above where I want to use it, you're kind of writing code in reverse. You're constantly writing functions up here, up here, up here, as opposed to like writing your code logically top to bottom. So let me fix this in a more standard way, which is to do this. Generally speaking, you do want to put the main part of your code at the top of your file. And in fact, I'm going to go so far as to define my function called main. It's not a requirement, but it's indeed a convention. And this just connotes to the reader that this is the main part of my program. I'm going to get rid of my empty hello call now and only pass in one version with hello name. And then down here, a couple lines further down, I'll actually define my hello function. Unfortunately, now that I've reordered the functions in this way, by putting the main part of my code at the top and hello at the bottom so that my logic kind of flows top to bottom, if I go ahead and run Python of hello.py, enter, nothing whatsoever happens. If I do it again, nothing whatsoever happens. Well, why in the world is this? Well, just because I've defined a function called main and I've defined a function called hello doesn't mean that I've actually called, that is, used either of them. Yes, I'm using hello inside of main, but no one is telling Python to actually use or call main. So in order to tidy this up, the last thing I need to do in this file, it seems, is actually call my main function. And in fact, by calling my main function in this way, it gets me out of trouble because now I'm defining main first, but I'm not calling hello yet. I'm defining hello next, but I'm not calling hello next. I only, at the very end of this file, call main, which has the effect of running this code up here, which has the effect of running this code down here, and it allows me, therefore, to organize my file and order my functions in any way I want, including main at the very top, and solving, ultimately, that problem of Python not knowing what's going on. Now, it's important to note that I defined my function hello as taking an argument, too, and then I passed into that function the value of the variable that I wanted to say hello to, that is the variable called name. Because suppose I had done something a little bit differently. Suppose that I hadn't defined hello as taking an argument, so I just remove mention of to and its default value world, and I go back up to my main function and I just call hello itself without passing in any arguments. And now let me go ahead and make one more change, one more mistake technically. Let me go ahead and just try to naively print out the value of name in the hello function. So now to be clear, in my main function on line 2, I'm defining my variable called name and assigning it the return value of the input function from the user. I'm then just calling hello. In my hello function, which now no longer takes any arguments, I am calling print, passing in hello, comma, and then immediately passing in name, the variable into which I got the user's input. But the catch is that name exists now only in main. And so watch what happens when I try to run this version of the program with Python hello.py. I hit enter. I'm prompted for my name, DAVID, enter, and a name error. Name, quote unquote, is not defined. So it turns out that this is actually an issue. of what's called scope. Scope refers to a variable only existing in the context in which you defined it. So insofar as I define this variable name in my main function, I can only use that variable in my name function. I can't use it, as I've tried to here in my hello function. It doesn't exist in that so-called scope. And so this is why now, if I rewind and undo all of those changes, you'll see that I'm deliberately passing main from my main function into my hello function. And now in the hello function, it technically has a different name. It's called to in that context, but that's fine. It's completely up to each individual function to name its own variables or name its own arguments. But this is a way now that I'm handing to the hello function the value of that variable so it can be printed by hello as well. And there's one final flourish we can add here. Now that we've implemented hello, you'll notice that hello only has a so-called side effect. It only prints out something to the screen. Well, what if I also want my function to not have a side effect per se, but actually hand me back a value? Recall that the input function returns a value, the string that the user typed in. Recall that the int function returns a value. The float function returns a value that was passed into it. Well, you can use one final keyword here, literally return, to return a value explicitly yourself. In fact, let me go back to VS Code here, and I think we'll return our attention to calculator.py and see if we can't implement one other version of calculator.py that actually has our own function that even returns a value. So I'm going to go ahead and open up calculator.py, and I think this time I'm going to throw everything away as before, and I'm just going to start practicing what we're preaching here. Define a function called main, which is now going to be the main part of my function. Let's go ahead and now declare a variable called x and assign it to the converted version of the user's input after asking them what's x. So again, a line of code quite like we've done before. And suppose now that what I want to do is square this value. I want to take the number that the user's typed in and raise it to the power of 2. So 2 squared would be 4. 3 squared would be 9. 4 squared would be 16, and so forth. Well, how do I go about implementing a function literally called square, which actually doesn't come with Python built in? Well, let me assume for the moment that it does exist, and let me say something like this. Let me go ahead and say that printing, how about x squared is comma square of x. So what have I done? I've defined a function called main, and I've implemented 2 lines. The first of these lines prompts the user for a value x and converts it to an int and stores it in a variable called x. On line 3, I then say x squared is, and then I pass a second argument to the print function, whatever the return value is of a square function. But square doesn't exist, and I'll show you this here. If I now call main at the bottom, and I run Python of calculator.py, I'll see that x is 2, and then I see a whole bunch of errors. A name error, name square is not defined. So this isn't a typo here, it's just the function doesn't exist, but I think I can make it exist here. Let me go ahead and define another function called square. This one's going to take in a number, and I'm going to call it generically n, as many a programmer would, just to represent any old number. And then what do I want to do in order to square n? Well, a number squared is really just itself times itself, so I'm going to do this, n times n. But it's not enough just to do the math yourself, n times n. You're going to have to return the actual value, n times n, and that's our new keyword here. When I now do this, watch what happens. Python of calculator.py, enter, x say shall be 2, x squared is 4. Let me go ahead now and say x is now 3. X squared is now 9. So I've implemented my very own function that returns the square of a value. And because I'm using the return keyword, that ensures that I can pass the return value of this, just like the return value of input or int or float, to another function, like print instead. And here, too, there's going to be so many ways to solve this same problem. I can actually raise n to the power of 2. We've not seen the syntax before, but if you use 2 asterisks like this, 2 stars, that raises the thing on the left to the power on the right. Or it turns out there is in Python a function called pow for raising something to the power that takes 2 arguments, the first of which is the number, the second of which is the exponent. So there, too, there's just so many ways to actually solve that same problem as well. So ultimately, what have we done here? We first introduced functions. These actions are verbs, many of which come built into Python that you can just use in your own code. We then introduced variables via which you can store those return values and then maybe do something more with it. At the end of the day, too, you now have the ability to invent your own functions to solve simple problems like hello, or in the weeks to come, much more sophisticated, more challenging, more fun problems as well. Well, here too,
there called area that takes in 2 parameters, length and width. Here I have my arguments. So down here only has what we would call a side effect, something that changes. You only see it down length times total area by a function any input. You can call what code should but somewhere else, somebody before you. So I've defined, and now I should see actually print a travel called gave as input to say. Now, if we're just using print, we haven't really added much functionality here to the say function, so why don't we have the machine able to say something, but then maybe append the emoticon at the end, so it kind of says something with emotion here. I'll go ahead and say print the phrase, but then also print on a space, followed by the emoticon itself up top here. So notice